プラベース編集長の松本です。今日はですね、アメリカのフロリダ州オーランドの方にやってきました。3年に1回開催されます4大プラスチック展示会の一つ NPE2024 の方にやってきました。展示会のメインコンセプトは Made for You ということで6つの展示エリアに分かれております。でその6つはですね、1つは材料、容器、リサイクル&サステナ、先端製造、金型、パッケージという構成になっております。広さはですね、建屋が2ブロックに分かれておりまして、東京ドームだいたい 2.4 個分ですね。で初日はですね、歩いてみたところだいたい15キロぐらい私は1日で歩いていたということになりました。で期間はですね、ちょうど5月の6日から10日まで5日間、長いんですけれども開催をしているということでございます。そして出展企業はですね、なんと200社以上ということで、コロナも挟んでますんで800社以上が新規の出展企業様だということらしいです。そしてですね、参加する皆様の国籍はなんと120カ国以上の方が、この会場に詰め寄るということで、とてもその注目度が高い、4大プラスチック展示会の一つということでございます。でプラベース的にはですね、日本勢はですね、材料は旭化成様ぐらいでですね、機械装置のところは松井製作所様だったりターモ様が出展をしているということです。やはり日本ではあまり聞き慣れない見慣れない展示会ではですね、企業様、特に今回で言うとですね、ライオンデルバゼル様とか LG 化学様とか、こういったですね、グローバルにはよく知られてるんですけれども、なかなか皆さんお話聞ける機会が少ないかなと思ったところに、突撃取材を行ってみたいというふうに考えておりますので、早速行ってみましょう。Hello, nice to meet you.
Nice to meet you.
So, tell us about your overview of your company.
So I work for a company called TotalEnergies Corbion. We're a joint venture of TotalEnergies, who is one of the world's largest oil and petrochemical companies, and Corbion, who is the world's largest producer of lactic acid. We're based in Thailand. Our production is based in Thailand. We have a 75,000 ton plant producing PLA. PLA is a bio-based material. So we, as you can see from here, we take sugar.
That's the sugar cane, right?
We take sugar cane that is fermented into lactic acid, and the lactic acid is then converted into PLA. So this PLA is bio-based and it is biodegradable.
Okay, well tell us about the NP highlights here.
So NP here, we're great. It's great to be here. We've seen huge numbers of visitors so far, and we've got certain things we're trying to prioritize for the customers. So if we come over here, I can show you some highlights. So one of the things you can do with PLA is you can make fibers. So we have certain special grades that can be used for melt blown, which are used for a range of applications. So we have applications such as masks. This is a PLA mask. With PLA masks. So this is has a SMS type structure. So it has a spun bond, melt blown spun bond to give you the filtration you require. This particular one is made in Korea.
Wow.
With our partner in Korea. We also have apparel type applications. So here's a t-shirt that's made out of it. This is actually from Japan.
Oh, this one? You mean the shoe?
The shoe is from Japan.
What? Never heard of it. What's the brand name? Never heard of this brand. No, but it's from Japan. Huh?
Yeah. So the upper is made out of partially out of PLA.
100% PLA?
It's not 100% the upper, but the containing PLA.
You mean the sole?
Not the sole. The sole is polyurethane.
The woven, right?
PLA is not so flexible, so you can't make it. Yeah.
All right. So it's the name of the product is Lumini.
Lumini is the name of our trade name for our PLA. If we go over here, we're having a big success in the medical arena.
Yeah, medical.
So we see this is a sample. So you go to the hospital, and then you can give a sample.
That's not a familiar size in Japan, though.
Okay.
But you see in hospital?
Yes, so this is for if you want to give
Samples.
me a urine sample for testing.
A urine sample?
A urine sample.
This?
Yes. All your details you can fill in at the place.
Okay.
And this is recyclable.
Yeah. I
So you
understand.
can take it away and you can chemically recycle it. So in a hospital, it's a closed loop system. So we can take the
I
material
see.
back and reprocess the material back to PLA.
I see.
And these are pill bottles.
Yep.
So
That's very familiar. I see in American dramas.
Yep. We also have these 3D printed materials. So we have, this is some little like that. This is a cactus, but it's actually toothpicks. These are toothpicks. So it's a toothpick dispenser, various things. These little cups are 3D printed. So PLA is the main material that's used in 3D printing. So it has a number of attributes. It sticks very well to itself.
Yep.
It has very, very good dimensional stability. And for a lot of home and office use, it has the advantage is it doesn't smell. So when normally with plastics, you heat them up and melt them, there's a very strong smell.
A very typical plastic burn smell.
PLA has no smell.
Oh, really?
So you can have it in your home next to your desk and you can 3D print, there's no smell.
Well, I think there's more and more 3D printing machines being used in home use, isn't it?
Yep.
So this is 100% like a filament of the 3D printing, is it?
Yep. So this is only PLA with a little bit of color to make it the right color.
How many grades do you have for the 3D printing for the PLA?
We have about 3 grades that are used for depending on whether someone wants to have a very fast.
Oh.
So we have certain printers now are working very, very fast, and you need a certain property of product to be able to work with those very high-speed printers.
So
Other one wants to have very high heat.
High heat.
So we have a higher heat version, and then we have a standard version
Okay.
that is used for everything.
Okay. Are you planning to have a more lineups?
We are working with some 3D machine
companies
to develop materials that have specific properties that they would like.
All right.
We also have here.
This is a projector?
No, this is a splint. So if you break your arm, you need to normally use plaster of Paris. So this is moldable. So you can
more flexible.
No, it's not flexible. If you heat it up, you can bend it and then it cools down. So, but the temperature you heat it up to is not very high. It's quite a low temperature. So you can do it without burning yourself, and then it becomes rigid.
This is made by injection, or it's not by 3D printing, right?
To be honest, I'm not sure what the process was.
I don't
for
think
that.
so.
Yeah.
Okay.
And we also working with various companies making
This is like a cosmetic
bottle. So they're sort of on the.
That's also
broader side.
aluminum.
Yeah.
Okay.
And then here we have the disposable side. So we do a lot of material in sort of clamshells, lids, sort of cold cups,
bottles,
for ice cream spoons.
Well, one thing that paid my attention was the coffee capsule.
Yeah.
And tell us about it.
So the coffee capsules, if you look and say, okay, K-cups is very big in the US, and the problem is they're made out of polypropylene and there's no end-of-life solution because there's a huge amount of coffee in there. The coffee prevents it from being recycled. You would have to open it, wash it, and it's very small. And it's too small.
And the material used in the capsule of the coffee pot is like aluminium, is it?
Is
aluminium, like not plastic, I thought.
Everything is PLA in this.
I mean, in general.
In general, the coffee cup would be
plastic.
It could be either plastic or it could. So if you take a K cup, it's plastic. If you take Nespresso, then they have aluminium.
Exactly, that's what I was saying. If it's
these are replacements for the Nespresso aluminium capsule. So for the aluminium capsule, they are recyclable, but how many actually get sent back? So you have at home, are you really going to open it up, clean it, put it in a bag and send it off? The actual amounts are very low. And what happens to the coffee? The coffee is really good for composting. So we make materials that go into a composting structure. They're rigid and durable enough to be able to withstand the pressure, and they're able then to produce the coffee. And then afterwards, you can put it in the composting bin, and then it goes off. And that all the coffee in there is useful for that.
Of course.
There's other things like tea bags.
Tea bags.
Tea bags is really big in Europe. They have the new plastic packaging waste regulation. that requires all tea bags to be compostable. So people think tea bags are compostable because they look like they're made of paper, but they're actually joined. Historically, they were stuck together with polypropylene, so they were not compostable.
I thought it's made by woven something.
Some are woven. There's two different sorts. The more expensive ones are woven. The cheaper ones are made out of a paper-like substance, and they so we see cellulose and cellulose fibers are glued together. But you look at it, it looks like paper.
And if
But
you see
in
the
reality,
package, it's plastic.
there was polypropylene in there. So now they're all replacing that with PLA. That's a big potential market for PLA. And we have bottles. So there's a bottle there.
Yeah.
That's from Korea, I believe.
A lot of things from Korea.
We do a lot of business in Korea. There's a noodle pot. So that's a foamed PLA. So this is foamed as well.
Oh.
And
Like an outrailing of PS?
It's like XPS, yes.
Oh, okay.
And so the one there is also from Korea.
Okay.
And is also able to withstand over 100 degrees centigrade.
Oh.
So you can put your boiling water in to make your noodles.
Ah, very good.
And then we have the cups, and we have a project with PepsiCo looking at replacing the chip bags with PLA containing material. So
what's the standard material being used for the chips package?
So historically, it would have been biaxially orientated PP.
PP, eh?
But there's a multi-layer structure. So there's
layer, right?
metallization and a whole range of different layers, and the
So
tie layers.
100% alterated by PLA, you mean?
No, the new one will be a range of materials. It will be compostable. There will be PHA, PLA, and
so many layers, right?
many layers, yes, 7 or 8 layers of
But
material.
which layer the PLA will become up?
In more than one layer. So there's tie layers, there's print layers, there's different layers that will have PLA.
And PLA sheets can be printable?
Yes, they're very. This is PLA. So this is like paper.
What?
But that's PLA. Obviously, it's very printable.
And this is like wrapping sandwiches.
Yeah,
and
so
stuff
we got one. Yeah, so you would put a burger in there or something else.
Maybe like something closer I've seen in the subway.
Yeah, so here's one for Boar's Head. Boar's Head is a.
Well, I don't know what's that.
It's a
Sandwich
branded
company?
sandwich company in the US.
Ah.
So
Okay. They wrap it up.
yeah, so they will wrap it up.
Okay.
And then we have the tea bags there. So but they're the packaging. They're the packaging for the tea bag. So you've got an individual tea bag. You want to make sure it's preserved. It doesn't it doesn't get in contact with oxygen because the flavour will destroy it.
Yes.
So that is a multi-layer structure of PLA with paper. So they want it to look like paper. So there's actually a paper layer on the outside, and then they need the barrier properties. So it's metallized. So it's PLA, metallized, and paper. But the metallization is done by sputtering. So it looks like there's a film of metal, but it's not. It's only tiny little dots of metal.
All right.
And when you go in the composting, it doesn't prevent it from composting, and it will go away. And those metal dots go to alumina, which is no problem for the soil and everything else.
All right. So those are the highlights?
They will be the highlights of what we're showing today.
Okay. Do you have any comments to people who watches this video in Japan?
I would just say that when we're looking at materials, you need to look at several aspects. First of all, it needs to work. So if you want something, it's just because something is bio-based doesn't make it good. It has to do the job first.
Yeah.
And then bio-based is helping meet certain commitments. Our materials are going close to carbon negative with some new modifications, improvements that we're doing in our processes. So there's massive savings on the carbon footprint from using our material. The materials are renewable, so it's not as if they're ever going to run out. Every year there's new materials being made for us to be able to process. And at the end of life, they are recyclable, and they are also chemically recyclable, but they're also compostable. So if they end up in the environment, they won't stay in the environment for thousands of years. They will, if in a compost, they will go away within weeks. If it's in the outside environment, they will go 10, 20, 100 times faster than conventional materials.
Thanks for your time.
Thank you very much.